first about this morning's discussion. So I was really thrilled to see that people are referencing the work that both the Insurance Institute for Highway Safety and Highway Loss Data Institute has done to try and understand the real world benefits in terms of safety of ADAS systems. One of the things that's important to mention is that these type of studies were possible because we were able to get manufacturers to provide us with information about which vehicles had which systems on them. This is very much a voluntary submission from manufacturers to us, so we can link it to either police report crash data or insurance data. Right now, insurers don't know anything about what's on the vehicles. Many of these systems are optional. The ones that are standard is a little easier to know. So for insurers to be able to provide discounts or maybe reduce premiums based upon these safety technologies, they need to know what cars have, what vehicles have this stuff on them so they can build up a loss history and understanding what's going on. And that was one of the things that was discussed this morning is what can the insurance industry do. Sharing of data is one of the crucial pieces. Sharing data specifically about what is on vehicles and what that means for potentially reducing crashes and loss is an important piece to that. So it was good to hear that. I'm glad that everyone finds the information we have useful. Related to the mission of our nonprofit organizations, we're looking for ways to reduce loss on the nation roadway. That's because of crashes that occur. The Highway Loss Data Institute also looks at the cost of vehicle ownership. Things like repairability, damageability. If you're driving down the road and your windshield gets cracked and you have to replace it and you have cameras behind the glass, it's no longer a cheap or simple thing to do. So what does the fitment of ADAS mean for simple things like repair? I'm going to talk briefly about our journey at the Institutes for learning more about ADAS technology, but really automation that's available in production vehicles today, and where we are, what we've learned, and kind of our insights during that process, both from our own testing and interactions with automakers. The way that we started things was really putting employees in vehicles with automation and other kind of ADAS features and having them drive these vehicles around on their own as a daily private vehicle and having them provide feedback to us about their experiences. So we didn't know anything. We wanted to start building up information about what happens in the wild or the real world, both in the Washington, D.C. area, which is one of our offices is located, but also in a more rural area in Ruckersville, Virginia, which is outside of Charlottesville. From this initial step, we got all sorts of insight about the problems that the technology was having, where it actually succeeded, where it could be improved, as well as people's perceptions of both ADAS and, at that time, adaptive cruise control. A follow-on to this was a more structured approach, where we had employees drive vehicles along a predetermined 20-mile route, both in the Washington, D.C. area along limited access highways and local roads, as well as outside of our Ruckersville test facility, which is, you're talking about arterials. High-speed roadways with controlled intersections, along with farm equipment that likes to go along these roadways and other kinds of interesting things like cows and sheep and things like that. So we had 20 employees drive each of these vehicles here with some type of partial automation in the vehicle, where you're doing lane centering as well as adaptive cruise control type of functions. After driving this route, they gave us feedback about their opinions on the technologies, on things like trust, as well as whether or not they thought these type of technologies improved their experiences while driving. One of the things that we found is that when we asked them to report their level of agreement with statements about trusting the vehicles to do vehicle control tasks like maintain speed and distance to a vehicle head, or keep the vehicle in the center of the lane, it varied. Depending upon the implementation in a certain vehicle, it also varied by function. A lot less trust in the vehicle technology to keep the vehicle centered in the lane, more stable trust in its ability to maintain speed and distance to a vehicle head. Now with this variation in trust, what we also found is that when you ask people about that automation as a package, what does it mean for improving your driving experience? We saw a really low percentage of people agreeing or strongly agreeing that the early version of autopilot improved their driving experience. It's likely related to the way that it did lane centering. Other implementations like Mercedes Drive Pilot, we had more than the majority of people thought that improved their driving experience. We followed up this with trying to understand what people thought about it. Okay, so one of the questions that we had for our employees was, give us one word to describe your opinion about this system. All right, and so for the Tesla Model S with autopilot, this is version 7. These are some of the things that we got. Right? Swirly, obstinate, untrustworthy. Mercedes with Drive Pilot did the opposite. So about 4 of every 5 people we had in the study said something positive. Smooth, helpful, seamless, right? So people, the important thing here is not necessarily rating or ranking how these vehicles are doing necessarily, but understanding people's reactions to them and trying to understand why that may be. You can see there's a lot of variability in the way that people are experiencing technologies that on paper are supposed to be doing the same thing. We looked at some other responses in that survey and related people's opinions about specific attributes of the technology to whether or not they thought it improved their driving experience. And what it boils down to, at least among our employees, this is a small subset, obviously not representative of everyone out there, is that the extent to which the technology is providing smooth inputs to vehicle control, whether that's inputs to steering or acceleration and deceleration, is going to be related to improving their experience. The other thing is what to the extent that the vehicle is doing what it's supposed to do, right? Detecting moving and stop vehicles, detecting lane markings, and the extent that that's relayed back to the driver in some sort of human-machine interface. Those attributes were most important to at least employees using these automated features in vehicles today. Now, building off what we learned from this study, specifically some more free response questions we had about, tell us about some instances where you were scared or didn't know what was going on. We started some functional evaluation of these same vehicles and some newer ones that we had purchased on the market. We've done this both on the test track and we're doing on-road evaluations now, and it's really, again, about information gathering and learning for ourselves what do these things do, what are they capable of, and can we actually develop a testing program to look at these partial automated driving systems. So these are the vehicle set. Now you notice we have that Model S that I had in the previous slides. That's got the version 7, but we also have the Model 3 with a more recent version of autopilot. And intention here is to see how things have progressed over time. We evaluated adaptive cruise control on our test track for these vehicles. And we're really just having the vehicle set in adaptive cruise control. It approaches a stationary target, which we use for our Ford automatic emergency braking evaluations. And we saw what happened. And this is typical of what we saw among the group. Not surprising, right? The vehicle's approaching a stationary object at about 30 miles per hour, slows down nice and comfortable, does a great job of stopping the vehicle. All but one vehicle did this. The Volvo didn't. It ran straight to the vehicle. When asking about why, in this implementation, Volvo ignores stationary objects, even at low speeds, with their adaptive cruise control system. Now, the automatic emergency braking will kick in and give you a full G of braking, right? So these are some of the challenges that people are encountering on the road, right? The extent to which you had adaptive cruise control handing off braking to an AEB system, and they're very different experiences. AEB will put, your stomach back in there, basically throw you to a lurch. Now, one of the other things that we've noticed is that you do this on the test track, and it's certainly not reflective of what happens in reality. Every single one of these excerpts is going to show you a situation with adaptive cruise control on approaching stationary traffic on a high-speed road at a controlled intersection. You'll hear forward collision warning in every single instance. All right, this is across all the different vehicles. We have a safety driver behind the wheel, one of our engineers, and it's very much the case that at speeds above 50 miles per hour, when you have adaptive cruise control on, it's not going to stop for these stationary vehicles. When asking manufacturers why, one of the responses, actually is a consistent response, is, well, we ignore this stuff at higher speeds, right? On these roads and on many roads, you're traveling at speeds below 45 miles per hour, above 45 miles per hour, but there are certain thresholds at which stationary objects are ignored for these type of functions in which they're not. To the driver, that distinction is not very clear, but there's a very real difference in the actual performance on the road. Now, another thing we found is that these less common hazards, right, that was talked about in some of the previous presentations, they don't do well. So vehicles that are stationary but not fully overlapped on the road or in the lane. We also have a situation here where the lead car moves around a dump truck following a tractor. These are some of the uncommon vehicles on the road. The Tesla actually starts accelerating once that vehicle moves out of its way because it hasn't detected that new vehicle ahead and it's resuming the set speed. These are illustrations of things that we've read about in the news with fire trucks and the kind of objects that are on the road, maybe parked cars or other response vehicles. Is this unique to the systems that we're testing in these studies? Our information suggests no. So we looked at twist and turn crashes for vehicles with automatic braking and vehicles without automatic braking. and the distribution of crashes of different types. And what we saw is that those vehicles with automatic braking are overrepresented in crashes where the circumstances are not optimal for automatic emergency braking, where you have the strike and a struck vehicle is turning, merging, or somehow the angle, the configuration is different than our typical test, which is full overlap, right? You're approaching the whole rear of the car. Once that changes, things become performance drops. You also have diminishing conditions, higher speeds, snow, ice, things about the real world, non-dry, sunny weather, diminishes performance. And these are areas that not only automation struggles with that's available in production vehicles, but the building blocks behind it, right, also struggle with. So when we're thinking about ways of improving self-driving cars or automation that's available now, those same improvements need to be made to advanced driver assistance systems to improve the safety that we have in vehicles or available in vehicles now, so we can get the benefits right away. So it's important to think about the entire ecosystem of these advanced vehicle technologies, making sure that they inform one another. And some of these insights that we learned for when developing automation can probably be used right now on ADAS systems to improve the benefit. In the last little series here, I want to talk about lane centering. It's kind of a unique beast. We drove these vehicles with hands off to the extent that we could, we misusing them on purpose around curves of different radii and going up hills, because these are areas that our employees mentioned problems. This is lane centering going up hills, right? And as you crest the hill, the camera behind the glass doesn't know where the lane lines go. And cars that we tested deal with this very different. Some wander a little bit in the lane, some decide to use up the whole road, right, while they hunt for the lane. Others kind of stay the course, maybe a dead reckoning approach. And there's very different, we don't know if it's a design philosophy or ways that what's happening under the hood is informing the algorithm that controls steering, but you get different outcomes. When we look at whether or not the car went out of the lane, you can see that there's actually a difference between the Model 3 and the Model S, software versions, right? So some of this is improving over time as there's exposure and experience. BMW didn't really stay in the lane at all. But part of this is their philosophy. They don't want the driver to experience a system that keeps itself in the lane well. Otherwise, they're worried about overtrust, right? So this doesn't mean that the vehicles can't do this. To some extent, the manufacturers don't want it to because they don't want people to think it can't. Now for curves, we see a similar variation in performance, right? So we have some vehicles that kind of just don't provide enough into the wheel to be able to keep it in the curve. Others take the curve very nicely. So this is a Volvo, again, it's going to stray from the lane, we have to intervene. But the next clip is going to be a Model 3, and it's going to take the curve just fine. Some of the challenges with this testing is that we find some vehicles it's more difficult to override the automation. So what when thinking about this, one of the things that we're seeing in the variation in performance of how well vehicles with the current automation take curves is the amount of authority that manufacturers have given the automation in terms of steering input. So Tesla, I believe, I think I saw Tesla here, may have give more authority to automation so that it can perform better under automated mode. BMW being a little more conservative and trying not to generate overtrust may provide less authority and allow the human to provide more of that input. So there is this partnership going on, and to the extent that the OEMs or other kind of manufacturers of this technology are giving more emphasis or more weight on automation's input or driver's input, is going to affect this partnership. That balance is not clear yet. It leads to this kind of variation in performance. What's the best course? We don't know. This is the kind of information we have. And so tying this into safety metrics is important. It's where we're really seeking information from manufacturers to know about which vehicles have which features, so that we can tie it to insurance loss data to evaluate whether or not these features are associated with reductions in both the frequency and severity of losses that these vehicles encounter on the road. So with that, I'm looking forward to discussions ahead.